Okay, let's talk about Apex stuff. So here, what you see is the screenshot of general workflow of Apex breathing and animation. The left upper corner, this one is, as you may know, the geometry that has already captured. And this guy is all skeletons. And first of all, you need to make sure to create this pack folder node. What this node does is just, collect all items you have, put all items together. And those four purple nodes following the pack folder are the one that creates actually this. As you can see, there is like a node for FX league. The FK transform league, and also bone capture league and IK league, the cut leagues. So yeah, those four are for leagues. Yeah, so like first pack folder, and then after that create leagues, and then after that you can create controllers for your leagues. Create controller. Now your geometry, skeletons, and leagues and controllers are ready to be animated. So it's time to add your character into the scene. Scene is kind of like where you are creating animations, and this node is where you are adding character into the scene. Yes, scene add character. If you already have a scene that has character animation in it, you can connect that scene into this first input. And this node is where you create actual animation, and its final node is called scene invoke, which evaluate your all Apex system, which evaluate scene animation and then base and character or joins. And I can say this is kind of rendering that we will talk it deeper in later weeks. Okay, so let's follow this workflow and apply this to our robot arm geometry. We have GeoCapture and we have a skeleton. First of all, you need to make sure to have pack those two. So create pack folder node. And okay, let's connect those two into the second input. What this node does is, pack each input and then, connect together. So if you look at the geometry spreadsheet, you can see just two packed geometry. If you disconnect skeleton, you will see just one. If you connect two, you will see two packed geometries. Okay, let's have a look at parameters. What we do here is create name for each input. If you look at a primitive attribute, there is a name attribute for each packed geometry, and those two are corresponding with those name attribute created here. And those two, like in default, is set to the input node name, but we want to have a good naming for those two. In most of the case, we use base as a name. Sorry, the base for the boss name and the skeleton, maybe. And then you need to also pick up a type. It's going to define the type of your input, like whether geometry or skeleton or whatever. If you click these tabs here, you'll be able to see a couple of options. Yep, shape, skeleton, the contour, character graph. So this first input should be set to shape, and this second input should be set to skeleton. Okay, now we have everything collected together into a pack folder. So we are going to create actual lists. In most of the case, we are going to use Apex Authority component node. So let's create it. So Apex Authority component node. What this node does is this node has a lot of like ready-made strong function for artists to create your gigs. If you look at this component tabs here, you will see blend shape, bone deform, and couple of other options ready for rigging. So let's connect this node, this pack folder into path input, and let's see what is actually happening. Most of the case we use FK transfer first, I guess. So let's pick up FK transfer. You will notice that there is an error message popped up. This is because if you look at this parameter here, it's picking up the guide skeleton from your source. But we don't have guide skeleton here. So we need to make sure to put guide skeleton in the second input to pack folder. Guide skeleton is a skeleton which has like extra attribute on your original skeleton. For example, like if you have character and character has like 100 of leads, 100 skeletons, and you want to create a lead only for your left arms, and if the guide skeleton has a tank attribute called left arm, you'll be able to easily pick up that part. You don't have to like select everything each by each. So let's create guide skeleton here. Maybe just copy this guy and name it as guide. We won't do anything at this point, but later we are going to create an attribute or extra point for the guide. Let's connect this one into the second input of the pack folder and name it as guide. So guide.scale guide.scale skeleton. And then look at the geometry spreadsheet. You can see like we have base shape, base skeleton, guide skeleton. Now we have like base shape, base.scale, guide.scale, and we don't see any error message on your authority component node. Okay, next let's go dive into deeper about this authority component node. If you open up a new panel from here, animation, if you open up the Apex network view, you will see like what is actually happening inside the authority component node. If you look at here, there is an input and there's output, and there's a couple of transform object node connected together. But like the color is like bit lifted, which means like everything's locked. So let's unlock them and have a look at the unpack folder node, which is unpack everything. But we just want to unpack a league, so unpack league, and then at the edit Apex graph node, which allows us to edit Apex graph. If you look at this, now colors get back to normal, which you have like control over everything. So let's optimize it a bit. Ta-da. Okay, here I optimize things a little bit, so let's see what is happening. On the left side, we have parameters, which has the base of skeleton input, and output we have also base of the skeleton here, which means this old system get information from base of skeleton and update, like create a new relationship, and returns new skeletons. If you look at here, you can see like there are like 6 input. We have cylinder B, cylinder A, R, hand R, A R, B R. R means rotation. So it's like getting rotation information, and then after that, it's creating our like parent transform offset kind of it. So here's a base and B, which is matching our parent relationship that we created here. And also, hand and cylinder A is connected to this A, and the cylinder B is connected to B. You might wonder why there's only rotation parameter promoted. Because if you look at this other component here, and if you go to controls, we have this promote group parameters, and now we only have this rotation parameters promoted. So if you want to make sure to have like already, so if you want to like make sure to have promotion for all parameters, I mean for transform, for rotation, for scale, you need to hit wildcard on this transform and scale as well. And you will notice that if you look at this edit graph node again and hit reset, you will notice that there is the transform and rotation and scale promoted here. Which means if you look at this auto D component again and hit enter here, if you don't have those two, hit enter and select one of like those rigs, you have only rotation. You have only rotation control on your B-pod. If you hit when you switch to like movement mode, but you won't see rotator, I mean P-pod. But if you have transform parameter promoted and also scale parameter promoted, you will see like you have like those transform and scale pivot here, which means you have control on the transform and scales. Cool. Go back to this edit graph again here and optimize a bit. So to summarize this, what this auto-D component does is get your skeleton information, also your transform information of your rigs, and create new relationship between them, and returns new base of scale, returns new base dot scale information. If you want to create your own custom network, you can add like node from your edit graph node. If you want to like create a new transform object node here, just hit tab and you can search transform object and you get a new one. Or if you want to like create new relationship between them, you can disconnect one of them and then connect to other one. Let's see what's gonna happen. Now this cylinder A is following. This cylinder A transform is following this arm A, right? Let's see. Yeah, this cylinder A is following this arm A. But what if I disconnect this and connect to arm B? Let's see. To see the result of updated rigs, you just need to, pack this information again into your original stream. So let's add the pack folder node here and pick up original stream into the first input, and then second input, you just need to update your Apex network here. Pick up base here. And I think the easiest way to check your updated result is to use this scene animate node where you can add animation. So let's see. See, it's like what we are seeing like something different from the original one. Here, this cylinder A was following this B, but here it's a bit updated. And when you wave up B, it's following this this transform. But you know, like when you think about like if you want to move your robot, which has like 100,000 of parts, this Apex network will be really messy. So most of the case, we are going to use this authority component node, and we are not going to do model approach. Okay, cool. Okay, let's have a look another the functions of the component here. Now we have like FK transform relationship between each digs, between each points, but we don't see the actual geometry here. So we need to make sure to our geometry follow those legs. So let's create another outer component, and let's pick up the bone deform here. This allows your geometry to follow the transform of the legs. So let's hit enter on your scene. Now you are seeing the actual geometry. And if you pick up the leg and move it, then you can see all geometry following it. Okay, before I talk about other functions, let's create controllers for each point. So create Apex control leagues, Apex configure controls. And yeah, pick up your league source from here. Pick up base of league. And then, for example, okay, let's create the league for A. So pick up, create new control config from here, and then type the name of the league on your control group. A. And you need to pick up the which shape you want to use for your league. For example, the box or board or whatever, but you won't see anything because the shape is too small. So let's turn on the shape offset and then make the scale bigger here. Now you have now you can see the shape of your controller. The box is not great, I guess. So maybe pick up the box with wires or board with wires. It's too big. Maybe smaller, and you can also choose your color, like white or red or whatever. I prefer to use red, so let's leave it with red. Cool. Now you have controllers for your arm. If you use like wildcard on here, you can pick controllers on everything, like hand and the arm B, and then your how it's called the base, and also cylinder A, cylinder B. Good. Now what we want to do next is create IK relationship for your arm B and arm A. So let's create another attribute component. And then pick up the IK. I always use this IK, smooth IK from here. And what this node does is create a relationship of the IK. So you need to create like, you need to pick up 3 points from here, like tip, mid, root. And this is going to create a really like arm, you know. So for the tip, we want to pick up hand, and for the mid, we want to pick up the arm A, and for the root, we want to pick arm B. So let's pick up them. Tip should be hand, and then mid should be arm A, root should be arm B. And from setting, you can control like of things from here. If you have like, if you are creating control on your like arm or legs, you can mirror those IK onto other side. But in this case, we won't use this one, so turn off this one. And also we can this storage fall off to 0, and main axis Z smooth IK storage. Maybe keep those 3. From this control tower, you can name the controller that you created. If you go to your viewport, it's hard to see, but if you move your mouse onto, for example, the root of the hand, you can see there is a point called arm IK handle I, which is matching with this port vector name. So like this is the new controller that was created on this outer component node. And also there's another one here on port I. This is the position of the mid. So if you move this guy, it's going to, you know, like keep the position between those 2 points, and yeah, moves like arm, which is really cool, right? Okay, let's create controllers for your IK handle. Now we have controllers for your base skeletons. Let's create another one, and we need to pick up the name from which is matching from here, port vector or IK handle. So maybe for an IK handle, we can create same type of controller for them. So maybe for asterisk or IK, and yeah, use shape override, pick up box wires, and then use color and make yellow. And if you make it a little bigger, cool. Now we have controllers for IK, which is working. So what this port L does is to decide the direction of those 3 nodes. If you move this around, the direction of those 3 nodes will match with it like this. Cool. And one more thing, we want to create the other component for this high school cylinder. So we want to make sure this cylinder A keeps look at this cylinder B, and cylinder B keeps look at this cylinder A as it moves. So let's create another attribute component node here. And then let's pick up the lookout from the tab here. Lookout. This is going to create a relationship between two locators, and then makes one locator keeps looking at the other one. We don't do anything on this first setting, first tab setting. Go to second driver settings. There's a couple of options. We have driver. We need to set up driver, and target and up vector. So first of all, we need to make sure to have a target point. Okay, so let's create target point on your guide geometry, guide skeleton. So let's get back to here, skeleton guide, and we want to create target for cylinder A, and we want to create target for cylinder B to look at. So what I'm going to do here is just going to, extract those 2 points and rename it as target, and then, combine them with original skeleton. So let's extract those 2 points. Extract those 2 using a brush node, and then we need to rename them as target. So add attribute string edit. Okay, so the name cylinder A as cylinder A underscore target, and then not here. Name skeleton A, name cylinder A as cylinder A target, and then name cylinder B as name cylinder B target. Cool. And we need to merge them together with original skeleton. And those targets need to follow this arm transform of arm A and arm B. So let's create another parent node, parent joint. Make sure your target for each arm A and arm B transforms. So create parent. So make your arm A as parent on this cylinder A target, and create your make sure you make your arm B to be parent of your cylinder B target. Cool. Okay, let's get back to our R3 component. Okay, let's get back to your original R3 component node. From the ribbon, you need to pick up your original point, and then from target, you need to pick up the target. So cylinder A point need to look at cylinder B target, and driver name can be anything, because it's like node which is going to be created first on this node. So maybe cylinder A underscore driver. And also this up can be anything. Maybe A underscore up. Cool. So if you move this IK handle I now, you can see this cylinder A is looking at this cylinder B target. Okay, let's create another one for our cylinder B. So create new setup here, and then put opposite thing from here. So the ribbon will be cylinder B, and then driver will be cylinder B driver. And then target is cylinder A target, and up will be cylinder A up. No, cylinder B up, I guess. If you hit enter here, oh yeah, the other parameter need to match with the first one. Eh. Now we can see cylinder is looking at each other. Cool. And those yellow controllers, driver, and then cylinder A up, we create from here. If we don't want to see them, we can just uncheck those points. And then, yeah, you have like more clear result. Nice. And yeah, as a result, we get something like this. We have controllers and we have good relationship for all rigs. Nice. So now the rigs are ready for your animation. Those four functions from Adobe component are the stuff that I'm going to use in the later part when we are going to move the actually robot. But if you want to try something else, yeah, feel free to go. There are a couple of other things, blend shape, the other spline. I've never tried everything, but yeah, I'm sure it's gonna be really fun. Thanks.